Let's start the session with a keynote address by a renowned ophthalmologist, Dr. Ronnie George. Dr. Ronnie is currently the Director of Glaucoma Services, Shankar Nethralaya, Chennai, Research Director of Vision Research Foundation, Chennai, serves on the Education Committee of World Glaucoma Association, is on the editorial board of Journal of Glaucoma, and is the section editor for glaucoma in the Indian Journal of Ophthalmology, was the past secretary of Glaucoma Society of India and the past president of the India ARVO chapter. Over to you, Dr. Ronnie George, to deliver the keynote on does PACG cause more blindness than POAG?
I'm glad to be part of KSOS 2021, and then thank both KSOS and Thomas George for the kind invitation. I'll be speaking about whether primary angle closure glaucoma causes more blindness than POAG. We all know that both POAG and PACG are major health problems globally, but PACG is more prevalent in Asia, and there have been a number of studies which have suggested that maybe PACG causes more blindness than POAG. However, since Asia is less well equipped to deal with many health issues, whether that contributes to the higher rates of blindness has always been a concern. One of the things with many of the population-based studies that have reported rates for blindness is that they typically have small numbers with disease. Even if you start off with 5,000 people whom you examine, you may land up with just 100 or 150 with disease, out of which even a much smaller number would actually have glaucoma. So we decided to look for blindness in glaucoma, POAG versus PACG, and we did a meta-analysis which has actually been published maybe a week back. The advantage of using a meta-analysis is that it adjusts for sample size. So some of the inclusion and exclusion studies that we used only population-based studies that use the ISGO definitions. We'll discuss that a little bit more. That reported data on both POAG and PACG in the same population, and that reported blindness proportions for each of these independently. So if we had publications from, let's say, the Rotterdam Eye Survey, they reported data on only POAG. There is no PACG data from there. Or if you look at some papers which reported data on both, but they did not give any detailed information on PACG. They would have mentioned one patient or two patients had PACG, but no further information beyond that. So those papers were excluded. I'll talk a little bit about the ISGO classification here because there are certain issues with the classification which we need to think about when we are looking at the analysis. So in order to standardize classification of glaucoma across population-based studies, Paul Foster and Harry Quigley suggested that you could actually decide whether an optic disc was glaucomatous or not based on the vertical cup to disc ratio. So what is recommended is that you do visual fields on every patient in the population, and those with normal visual fields, you look at their optic disc distribution, and based on the distribution, you classify those visual fields as being suspicious or not. They also suggested some modifiers such as visual fields and intraocular pressure. And they came up with 3 levels of evidence. Level 1 evidence was when the vertical cup to disc ratio was higher than what would be seen in the 97.5th percentile in the normal population, and there was a visual field defect compatible with glaucoma. Now, this is perfectly okay, then this is how most of us would actually diagnose glaucoma. Level 2 was if a visual field defect could not be performed satisfactorily. So then if you had a vertical cup to disc ratio which was greater than the 99.5th percentile in the normal population, you would consider that patient to have glaucomatous, glaucoma. But what if you could not see the disc and the patient could not do visual fields? Then you had level 3 diagnosis, where the visual acuity had to be less than 3/60 and had an IOP exceeding the 99.5th percentile of the normal population, or there was evidence of previous glaucoma filtering surgery with a visual acuity of less than 3/60. So just to put in perspective, in the Chennai glaucoma study, a VCDR of more than 97.5 was a 0.7:1 cup disc ratio. 99.5th percentile for confidence ratio was 0.8. And for IOP, the 99.5th percentile was more than 30 millimeters of mercury. So they're fairly robust guidelines. For primary angle closure disease, they suggested that an angle in which more than 270 degrees of the posterior trabecular meshwork cannot be seen, be considered as narrow, along with the disc changes as we have just discussed in level 1. This is, of course, there are a few issues with this, which I will again discuss a little later. So we carried out a PubMed search between 2002 and 2020, based on these keywords: population-based primary angle closure glaucoma and prevalence, and the same with primary open angle glaucoma. We limited it from 2002 to 2020 because this was when the ISGO definitions came out in 2002, and we did not include studies that had been done before that. So when we went through the database, we found a total of 313 articles, out of which 208 for POAG and 105 PACG. We screened the abstracts of all the articles and the titles. And after we removed duplicates, we landed up with 286. When we went through the abstracts again, we realized that about 240 of these were did not fulfill our eligibility criteria, and we removed those. And then we had full text articles assessed for the remaining 40, from which we excluded 14 because they did not fulfill our eligibility criteria. From those cross references, we found 4 more, and finally we landed up with 30 articles of 23 studies. And these 30 articles were distributed globally. So you had 1 from the US, 1 from South America, 1 from Iran, 1 from Nepal, 4 from India, 6 from China, 1 from Bangladesh, 4 from Singapore, and 1 each from Korea and Japan. So they're fairly widely distributed, with, of course, clustering seen in Asia as expected. So these 23 studies had 78,000 odd participants. And even with this huge number of participants, you had 1,704 POAG and about 724 PACG, with 151 of those with POAG blind and 196 of those with PACG blind. So even with these large numbers, when you look at the total number of people with glaucoma, it's not all that huge. It's about 1% for POAG and 2.5% for PACG and 2.5% for POAG. The blindness, just as a percentage, in PACG was about 26% and in POAG was about 8%. So looking at it grossly, it definitely looks like there's much more blindness in PACG than POAG. But keep in mind that this is just the entire population as a whole and not within each study region or within each study. So we try to look at the ratio of PACG blindness to POAG blindness. And here again, you'll find that except for these 4 studies, the Namil Eye study from Korea, the Projecto VR from the US, the West Bengal Eye study, and the Iranian Eye study, and the Singapore Indian Eye study. In general, you found more PACG blindness as compared to POAG blindness. And this is a very, very busy slide, but I just showed it here to point out that the highest number of proportion of number of eyes with POAG was in a study from Japan, and the highest number of eyes in PACG was in a study from Beijing. So these numbers of 90 and 150 show you that even if you have 10 people with blindness, it's not a very large number to be able to get statistical significance. And you can see that in many of those studies, you have people with PACG in single digits. POAG numbers are also generally healthier than the PACG numbers, but not very large consistently. So we use the Revman 5 software to analyze this. Studies with 0 blindness prevalence values were assigned a token value to help in the analysis, and we used a random effects model since there was significant heterogeneity among the studies. So I'll just share with you what a forest plot looks like on a meta-analysis. So basically you have this line in the middle, which is the line of no difference. And this is one option, let's say PACG causing no blindness, and this is the second option, which is POAG causing no blindness. You would land up for each study with a line like this, which shows you the 95% confidence intervals. And this in the middle is the actual relative risk for that study. So it might be favoring one option or favoring the other option unequivocally, where the entire line is on one side or the other side. Or you may have something like this, where it's crossing this line. In this case, you do see a bias to one side, but because of the wide confidence intervals which cross the zero line, that you cannot actually claim that one is more likely to cause blindness than the other. The size of that little sort of a triangle in the middle could also tells you the proportion that it contributes to the overall results. So now I'll just share with you our cumulative risk ratio for blindness for PACG versus POAG. And so we had, as I mentioned, we had 724 and 1,702 total events. And when you look at this, you see that most of the studies are actually on suggesting that blindness was higher in PACG. But many of these actually cross the center line of no difference. And you see maybe just one study here where you found a ratio which was favoring POAG. But there, the confidence intervals are very, very wide, and that overlaps this. And when you look at the entire data together, you'll end up with a fairly robust estimate with not very much, not a very wide confidence interval, which suggests that the cumulative risk ratio of blindness with PACG is 2.4 times that of POAG. So this is fairly definitive, and you can see that this is quite different from the ratio that I showed you, because here, once you have adjusted for the sample size, you get you get more robust information. The next thing that we were concerned about was something that we had noticed in the Chennai glaucoma study, and that the POAG prevalence was actually much higher in the urban population than the rural population. It was almost double that. Few years after that, when they reanalyzed the APEX data, they also found similar results. So we were wondering whether rural-urban differences actually account for these differences in PACG. Because you have so much more POAG in the urban population, is it because they have more severe disease? Are we going to see a reversal of the ratio if that happens? And you can see that you have studies which are distributed all over rural, urban, and combined. And this basically shows you the rural segment, the first plot. And here in the rural segment too, you can see that the odds ratio is about 2, the relative risk was about 2.3. In the urban, it was about 2.65. And there were just two studies which had had a mixed population. And there too, the odds ratio was 3, the relative risk was 3, but this actually overlapped the line of no difference, possibly because of the modest numbers included there. We also wanted to see whether the definition of blindness, because different studies use different cutoffs, 3 by 60, 6 by 60, and some use visual field blindness definitions too. We wanted to see whether this made a difference to your risk of, and then when we looked at studies that used visual fields in addition to the visual acuity criteria, reported a 1.9 times relative risk of blindness with PACG as compared to POAG. Studies that did not use visual fields report a slightly higher 2.64 relative risk for blindness with PACG as compared to POAG. But if you look at those confidence intervals here and here, they overlap, suggesting that these two results are really not very different. And whether you use visual acuity criteria or not, it did not seem to matter in terms of the risk of blindness with PACG. When you looked at visual acuity criteria, whether you used less than 6 by 60 or less than 3 by 60, the risk ratio for higher risk with PACG was very similar, 2.4 for both groups. The other concern that was there is many of the studies, including us and most of us in India, use 180 degrees to define angle closure instead of 270 degrees. When we looked at our studies that we included, almost 50% of the patients, almost 38,000 patients were defined using the 180 degree criteria. So we wanted to see whether this makes a difference. And here too, you find that if you used 2 quadrants, you got a risk ratio of about 2.6, whereas if you used 3 quadrants or more as angle closure, you got a risk ratio of about 2.29. Again, the confidence intervals overlap, so there's really no serious concern here either. It is consistent whether you use different definitions or not. So these confounders did not change the risk of blindness with PACG compared to POAG substantially, whether you were rural or urban. whether the blindness visual acuity criteria were used or the visual field criteria were used or both, and whether angle definitions played a role. We'll try and discuss for a few minutes as to why PACG causes more blindness than POAG. So we looked at a few things here: age, severity of disease, IOP fluctuation, and availability or quality of health services. So I'm going to talk mostly about the first three, and this is partly from the papers that we studied and partly from reports from elsewhere. So the first question was, are patients diagnosed to have angle closure glaucoma older? And when we look at some of these studies that I shared with you today, you can see that patients with PACG are actually older by about 2.5 years. But whether this 2.5 years is enough to account for a 2.3 times greater risk of blindness is unlikely. So the older age possibly may point to maybe slightly a later age of diagnosis. We are not sure. Does IOP play a role? And in general, in at least these three studies which reported it, eyes with PACG had higher IOP than POAG. The other studies either did not report it or it was similar numbers. So perhaps eyes with PACG have higher IOP than POAG. And this seems to be the case even in clinic-based studies. For example, this is a paper from Gaskazer and colleagues. Relatively few numbers, but these are fresh people who newly diagnosed POAG and PACG. And you can find that the IOP at presentation was almost 8 millimeters higher than the PACG group. Then, when you look at the severity and spatial distribution of visual field defects by the same group, you find that the mean age was similar. The IOP at diagnosis was higher in this group. This is a slightly larger population than the previous one that I showed you. When we looked at diurnal intraocular pressure and its as a risk factor for angle closure and open angle glaucoma, and this was published some time back, and you can find that with PACG, you do find that the IOPs were higher, statistically significantly higher than with POAG. And these diurnal fluctuations were not noted to be a problem when Dr. Amanjit published this information from India. But you can here also see that the group with the highest fluctuation had more eyes with PACG than POAG. What about severity of visual field defects at presentation? And here, this is a paper that I referred to a little earlier. You can see that the PACG eyes had almost 4 decibels more of loss as compared to the POAG eyes. And putting all this information together from the paper from Gaskazer and Paul Foster, you find that not only was visual field a little worse, it's not statistically significant, possibly because of numbers, but IOP was definitely higher in this group. And this group in their population was similar age as POAG. What about other factors? So one of the issues is when you look at the proportion of undetected glaucoma, in the developed world, about 40 to 50% of glaucoma has been detected. While in developing countries, 70 to 90% is undetected, and angle closure is commoner in our countries. Misdiagnosis of PACG is one of the other issues that you have, and I'm going to share with you some of the information we have from the Chennai glaucoma study and the Andhra Pradesh eye disease study. So cases diagnosed of angle closure glaucoma in the study were looked into, and we looked at those who had a prior diagnosis of glaucoma. And among those patients, we looked for the records and to see what proportion of these were being treated as POAG. We assumed that if they had not had a YAG peripheral iridotomy, or they were not on pilocarpine, or their records did not mention gonioscopy, they were being treated as POAG. And what you will find is very similar results. 60% of those detected to have angle closure glaucoma with a prior diagnosis of glaucoma in the Chennai glaucoma study were being treated as open angle glaucoma. And 67% of those in the Andhra Pradesh eye disease survey were also being treated as glaucoma. So one of the issues here is with angle closure, unlike with POAG, even once you start medication, unless you have taken care of the angle, you are susceptible to intraocular pressure spikes going forward, which could definitely increase the risk of disease progression and increase the risk of blindness. So glaucoma blindness with POAG versus PACG, who goes blind? And it does appear that PACG causes significantly more blindness than POAG, in fact 2.4 times greater risk in population-based studies. This may be related to the more severe disease at presentation, but just highlights the fact that we need to be a little bit more careful about examining our glaucoma patients and looking for a narrow angle. And proactively looking at the optic disc and taking care of them as required. Thank you.
Thank you, Dr. Ronnie, for the excellent talk.